Thank you for joining me on Project Statistics YouTube channel. Today, we're going to talk about parametric and the non-parametric statistics in SPSS. Statistical tests are used to analyze some aspect of a sample. In practice, we want the results of our test to be generalizable to the population from which that sample was drawn. In other words, we want the sample to represent the parameter of the population. Normally, when you are doing research, you take a sample from a population, research on and make your research on that sample and generalize your results to the whole population. And most of the time, we want to have a research that is generalizable. And what that means is that the parameters of your sample must represent the parameters of the population for you to be able to generalize your findings from the sample. So when we know that the sample meets this requirement, we use what we call the parametric statistics. And now, what is parametric statistics? Parametric statistics involve statistical techniques that assume the data follow a normal distribution. Now, these methods they make strong assumption about the parameters of the population. The use of parametric statistics require that the sample size be normally distributed, that the sample size, that the data, the sample data have homogeneity of variance, is also be continuous, and the parameters of the population are fixed and known. So having known what parametric statistics is, now what is non-parametric statistics? Non-parametric statistics do not rely on distributional assumptions. They are used when data does not meet the assumption required for parametric methods. Some of the key features of non-parametric statistics is that they do not assume a specific distribution. So normality is not a problem for non-parametric statistics, and most time they work well with ordinal data or nominal data. They are more suitable for sample size that are small and skewed. They often use rank instead of raw data values. Non-parametric statistics make fewer assumptions. Such tests also have reduced ability to detect significant differences. So it should be used only when necessary. Let me say that again. Non-parametric statistics they make fewer assumptions, and such tests also have reduced ability to detect significant differences. So it should be used only when necessary. Some parametric methods are considered robust to mild violation of assumption. What it means is that there are some situations where you will run your normality test and you discover that your data distribution is not normal, and you can still go ahead to use your parametric statistics to analyze your data. What that means is that there are some, for example, independent sample t-tests can tolerate slight non-normality. In other words, they are robust and they can, tolerate mild violation of assumption. So most of the time, you are encouraged to use your parametric statistics to run your analysis. That's why you see that most time the parametric statistics are more popular than the non-parametric equivalent. So most of the time, you can see yourself using the parametric statistics even when your normality test is violated. When there is a mild violation, some of them, because they are robust to violation, can also use parametric statistics to do your analysis. Now I'm going to give you some of the analytical tests you can do, which are parametric and non-parametric, and some of their differences. One is the parametric statistics require distributional assumption. That means you have to be normal. Your data value have to be normal, while the non-parametric does not have much assumption in terms of the distribution of the data. And two, the in parametric statistics, you have integral or ratio data, which is also continuous. You can say that the data must be continuous. And example of this is independent sample t-test. Independent sample t-test, the non-parametric equivalent of independent sample t-test is Mann-Whitney t-test, while in ANOVA the non-parametric equivalent of ANOVA is Kruskal-Wallis. Pearson correlation is a parametric statistics, and the Spearman rule is non-parametric statistics. That's why when you are running your correlation analysis, if you discover that your data is not normally distributed, you use Spearman rule correlation to run your analysis instead of Pearson. You only use Pearson when your data is normally distributed. So this is very important for people that are using correlation analysis. You should be able to know the difference between Pearson correlation and Spearman rule correlation. Then we also have the pair sample t-test, which has equivalent of 𝐨𝐴 sign rank test. Then we have the linear regression, which is a parametric test, and its equivalent is a logistic regression. And we also have the repeated measures ANOVA as a parametric test, while the equivalent is the non-parametric equivalent is Friedman tests. So this is a good overview of understanding parametric statistics. So when you want to, do your analysis, it's very important you have all this information so that you'll be able to make the right decision.